So today we're going to talk about function composition. You're going to want to make sure you, as always, you're putting your last name and your first name on the top of the page. So I'm just going to add mine for now. Please make sure it's yours, not mine. And then our essential question is, how do you compose two functions? And then we have two I can statements. I can compose two functions together algebraically, and I can evaluate a function composition given a graph. If you need to, you can pause the video to write those down. So function composition has a kind of a crazy notation. We have two notations that mean the same thing and they're interchangeable. So the composition of functions the function f with the function g is the following. So sometimes they'll call it fogging and coughing, but it's called f of g of x. That's how it's written, or f of g of x. And you'll notice what's going on is I have a function that is inside of another function. So I'm going to substitute it in. I'm going to substitute one function into the other function for the x value. It's kind of like the substitution method from systems of equations. So the domain of f of g is the set of all x in the domain such that g of x is in the domain of f. So basically, your domain has to be in both functions. So what they gave us two functions, g of x and f of x, and they want me to take f and substitute it in for g. Sometimes it's easier if we rewrite it so you can see which one is being substituted in. So I'm going to write out my g function, but instead of writing my x, I'm going to write a set of parentheses. Then I'm going to take and I'm going to substitute the f function into the g function, so x squared minus 2x. Now I'm just going to go ahead and solve my algebra just like I always would. I see a 3 that I need to distribute, so I'm going to go 3x squared minus 6x and then plus 4. And that's it. So we're going to try this again in example 2. Okay, so it looks like this time I have g of f of x. So I'm substituting the f function into the g function again. So I'm going to write out my g function the way it looks. It's 2 times something squared plus 2 times something. So I'm going to take my g function and I'm going to substitute it in. So x minus 3 and x minus 3. All right, whenever we see something like this with a squared on it, that does not mean just square each individual piece. It means I have x minus 3 times x minus 3. So that's an indicator that I need to FOIL that, okay? So I'm going to write this out neatly and differently. This is probably more than I would write out when I'm just doing the problem myself. So this is what that really means. At the same time, I'm going to distribute that too. So 2x minus 6. All right, I'm going to FOIL. Okay, so when I FOIL, I've got x times x, which is x squared. X times negative 3 is negative 3x. And then I have another x times negative 3, which would be another negative 3x. Negative 3x and negative 3x is negative 6x. I'm kind of shortcutting it. We are in Algebra 2 with trig. We don't need to write down every single little step. We can do some of the work in our head. So negative 3 times negative 3 is positive 9 plus 2x minus 6. I'm going to distribute that too. So 2x squared minus 12x plus 18 plus 2x minus 6. And then I've got 2x squared, negative 12x, and positive 2x is negative 10x. And then 18 minus 6 would be positive 12. All right, let's try a couple more. We're going to go up through example 4 in this video. So we're going to go ahead. We already have it written where we can see where the substitution in is really good. So we're going to take g and we're going to substitute it into f. So I'm going to write out my f function the way it looks, but anytime I see an x, I'm going to put a parenthesis. So parentheses minus 1. Now I'm going to take my g function and substitute it into the parentheses. So 2x squared minus 1. I really don't need my parentheses. I could combine like terms. So I've got 2x squared, negative 1 and negative 1 would be negative 2. So that one was a lot simpler than the last few. All right, I've got my g, and it says I'm supposed to substitute into f, so I'm going to write my f function first. So I always write my outer function first. So I've got parentheses squared plus 4. Now I'm going to substitute in the g function into where the x value was, and there were the parentheses. So 4x minus 5. As we learned in example 2, we have to write 4x minus 5 times 4x minus 5 in order to get this correct. And I'm just dropping down the 4. So we have 4x times 4x, which is 16x squared. 4x times negative 5 is negative 20x. Another negative 5 times 4x is another negative 20x, so negative 40x. Negative 5 times negative 5 is positive 25 plus 4. So I end up with 16x squared minus 40x plus 29.